A researcher wishes to see if there's a relationship between the hospital and the number of patient infections. A sample of 3 hospitals is selected and the number of infections for a particular year are examined. Below, the data is summarized. Okay, so there's 3 different types of infections. They looked at the infections that occur at the surgical site, infections from pneumonia, and infections in your bloodstream. Okay, so it's all summarized on a contingency table, and we'll come back to this. All right. So given this information, can it be concluded that the number of infections is related to the hospital where they occurred? So we'll use the 1% significance level. All right, so to do this, we're going to use the independence test, and that again uses the chi-squared distribution. So the alternative and null hypothesis for the independence test talks about the independence of the variables. So the variables that we have are the number of infections and the hospitals and where they occurred. So our null hypothesis will say that the number of infections is independent of the hospital where they occurred. The alternative hypothesis will say that the number of infections is dependent on the hospital where they occurred. All right, so the significance level of the test, we are going to test this at the 1% level, so 0.01. This is a chi-square test. That's always right tails, so we'll type that in. Now the degrees of freedom, here this is equal to the degrees of freedom will be the row sum minus 1 times the column sum minus 1. So, number of columns, I'm sorry. So the number of columns that we have are 1, 2, 3, and the number of rows that we have are 1, 2, 3. So let's see here. So this will be, the number of rows is 3, then we subtract 1. Close that, then we're going to multiply it by the number of columns, which is 3 minus 1. We'll close our parentheses and click enter. Okay. Now we need to determine the critical value for the test. All right, so this will use the inverse chi distribution. So chi inverse, we're going to look at the inverse on the right-hand side. The probability that we're looking for is 1%. And then the degrees of freedom, don't forget your comma, the degrees of freedom that we have are 4. Close the parentheses, click OK. So our critical value will be 13.27. All right, now we're going to calculate the test statistic. And this takes a little bit of work. We're going to have to calculate, we're going to look at the observed values minus the expected values and then compare those to the expected. All right, but we have a lot of observed values. So let's come over here. These are our observed values. Okay. And what we're going to calculate down below is this table here for the hospital expected values. To do that, we're going to need to know the sum, the row sum and the column sum, and we'll divide it by the total. So let's go back up here and figure out the row and the column sums. So just using a formula, this will be equal to the sum, and we'll just do this column here, and then let's close the parentheses. Okay. Click OK. All right, so the first one is there. Now, we could do that individually, but we can also sum and tell Excel to sum for us across columns. So if you're on your computer, you'll be able to drag. I'll click on my tablet. I'm going to tell it that I want to fill, and then move this over. And there it fills in the other 2 columns. Now you can see the total column is 0 because we don't have any sums there. But now we can do the sum there. And this is the sum. And now we're going to sum across columns. Close your parentheses, click OK. There we get that sum, and you can see the bottom right-hand corner automatically updated, and then we will fill. So we want to fill and fill in the remaining, and we'll watch that bottom one change. Okay, So there we have it. In total, we have 582 different infections. Now I filled in a lot of the values for the expected values, so I'm going to clear this out to show you how we can do this. Okay. All right, so the way you want to do this then is that this is equal to, now we're going to take the row sum. So this is the first row, the first column. So here is the first column. We're going to multiply it by the first row, that sum, and then we want to divide by the total number that we get. And click OK. So that's how we get the 50. Now, as we move over here, you want to be careful about this. Let me delete it so you can see it happen. This will be equal to, now we are in the first row, so we'll take the first row sum, and we are in the second column, so we want to multiply that by the second column sum, and then we divide by the total. Enter. Okay, let's pick another one just for good measure. Let's say we wanted to do, let's do this one. Okay, so let me clear that out. There we go. Okay, so now this will be equal to, this is the third row, so I want to take the third row sum, multiply it by the, this is the third row with the first column, so I need the first column sum, then we'll divide that by the total. Enter. Okay, and I'll leave the rest of them for you to do, but you have to fill in all 9 boxes there. Once we know the expected values, we can start calculating the test statistic. Remember, the chi-square test statistic says we're going to look at the observed, the distance between the observed and the expected value. Then we'll do it in a stage, we'll square that, and then finally we'll divide it by the expected value. So one way to do this is it's easier to have it in these columns. So again, let me show you what I've done here. I've made a formula that said this is equal to the cell that it's into. And this one's equal to the next cell, etc., etc. And you can do the same with the other ones. So you don't have to try and cut and paste all of that. All right, but now we're ready to do the observed minus the expected. So this is equal to, the actual is our observed value. We want to subtract off the expected, hit enter. Then we will carry that down and fill it, oops, for all that we have. Okay. Then we can take the squares of all of those. So this is equal to this cell. We want to square that, hit enter, and fill that for the remaining. Then we come over here and we say we want to take that and divide it by the expected value. And the expected value is found there. Click enter. And then we want to fill that and bring it down. Okay, so easy, easy. And now all we have to do is calculate our test statistic, which is the sum of these. So this is equal to the sum of, oh my goodness, the sum. All right, let me try again. The sum, just type it, open the parentheses. This is the range that we would like. Close the parentheses, click OK, and there it is. There's our chi-square test statistic, 30.69. Okay, now that we have our test statistics, let's go back to our calculations here. So we have the critical value, the expected values we've done. Now we know the test statistic, and just to keep everything nice, let's say this is equal to, and that's the test statistic, so we'll just put it in there. And that'll help us now, we can determine the p-value. The p-value, we're going to use the chi-square distribution. We'll be calculating values to the right. So this is our test statistic. The degrees of freedom we calculated earlier at 4. Close the parentheses and click OK. So you can see 3.53 times 10 to the negative 6. This is effectively 0. So we can make our conclusion in a couple different ways. Based upon the p-value, this p-value effectively 0 is less than our significance level, which is 0.01. Therefore, we will reject H sub 0. Okay. Now, we also could have done it based upon the critical value. So with the critical value of 13.27, we look at that. Our test statistic is greater than that. That means it's in the critical rejection region, so we will reject H sub 0. So either way we do it, we're rejecting H sub 0. Okay, so just to have a nice summary of all of this, here's our question. Can it be concluded that the number of infections is related to the hospital where they occurred? We've stated our null and alternative hypothesis. We've decided to reject H sub 0, and so what that would mean is that at the 1% significance level, there is sufficient evidence to support the claim that the number of infections is dependent upon the hospital where they occurred.